So, hello everyone. Hopefully it works. So I'm gonna have a small talk. It's only gonna be 20 minutes. It's not gonna be too technical, so it's suited for everyone. On buffer overflows and how they work nowadays when you have Gen AI everywhere. So this is my personal research for my third year project, bachelor project. So I have to shout out Anne Kayem if you're here, my supervisor. Thank you very much. So this project, I did a lot of testing on different models that we have publicly available, and very surprisingly, the results are quite scary. So let's go straight into it. So why does this buffer overflow still matter nowadays? This is an attack that was present since 1972. At the time, it wasn't named buffer overflows, but it was already identified as such. And still, the rankings, CWE rankings, are not here since 1972, but it's been considered in the top 25 since 2011, if I'm not mistaken, and it's been fluctuating between second, and so last year, 2024, it was in second place, and now it's back in fifth place. Still quite scary. So still relevant to today, and most memory, so as the talk before talked about Go being a memory safe language, C and C++ are not memory safe languages, and they do have buffer overflows when developers don't take it carefully enough and don't check their boundary. So existing compilation mechanisms that have, so ASLR, DEP, stack smashing protections can be bypassed with stuff that we call rope chains, return-oriented programming. So I'm not going to go too much in depth, but just so you know, we have defenses, but these defenses can be bypassed. So that's quite scary. Legacy code bases, especially in IoT devices, most of the time don't have these compilation mechanisms, so that's what's more inclined to be attacked. And what the research showed is that the static analyzers that you might use in industries such as SemGrep or SonarQube actually did not perform very, very good. And the code base and the code snippets that I use to do these tests are quite easy. So it's very scary. Gen AI semantic code understanding does seem with this research much better than the syntactic analysis that the static analyzers have. So yeah, let's go straight into it. Quick recap. I know I said it wouldn't be too technical, but you do need to understand how buffer overflows work. I'm not going to go too much in depth, but the stack grows down, the heap grows up. This is a structure of a compiled C language. It does vary depending on your operating system, depending on your architecture. So if you compile in 32 bits or in 64 bits, it will vary. But more or less, it looks like that. If you go more in depth into the stack, you'll see that there is a layout, and it still grows down. You have your function arguments, if you have some. Then you have your return addresses, your save old pointers, your local variables, and if someone initializes an array, it's going to be just here. You're going to ask, okay, why is it dangerous? Because if someone does not check exactly what is going on and doesn't check their bounds, these variables stored in an array might overwrite on top. So if I told you it grows down, you're going to tell me, how am I going to be able to write up top? Because array stored in memory is contiguously incrementing. So if I write over this 32 array that I defined, I'm going to start writing my local variables. Can be an issue, okay. If I continue writing, I'm going to write over the base pointer. It's going to be a bigger issue. And if I continue writing, I'm going to overwrite the return address, hijacking the total control flow. So that's a big issue. So if that's clear, I can now proceed and tell you about my research questions. So what was I trying to prove? What was I trying to analyze? So firstly, can AI detect buffer overflows in C code? Easy question. Okay, this is probably going to be responded with yes or no. Then Gen AI, does it compare properly with static analyzers? This is a question where there were a bit more doubts. I didn't know how it was going to go. Maybe static analyzer would be very good, Gen AI bad, and my research would stop here. It's going to be a tidy third year project. Third question, does prompt engineering methodology, so single versus multi-stage prompts. We know a lot of research does suggest that multi-stage prompting is better for better performance and for better optimized results. Surprising results here. And finally, this research question here is a bit particular, the fourth one, because it wasn't initially planned in my research. It came after, since I made the literature review initially, and in the between of my literature review and my dissertation, OffSec came out with the OSAI certification, and I I discovered a repo called PSSW100 AVB, which is one guide that bypasses antivirus with a single prompt, a single comment, inline comments, and mine manages to bypass AI antiviruses. So that showed me the importance of invasion techniques, and I definitely had to add it to my project to see how it would perform here. So let's see how that did, and exactly what is my pipeline. So first, I designed vulnerability. So I designed 2 stack vulnerabilities, 2 heap vulnerabilities, and one that is an integer that after maps to a heap vulnerability. You might see, so the CVE 2025 6660, this is a vulnerability in the PDF XParser software and the way they parse GIF images, and this led to a nice integer overflow. It's quite recent, so it was very relevant for our research here. To do that, we stripped the comments that we initially have, and we made Bond tool salt scripts to make sure that what we exploited was replicable in all environments. And then we tested SendGrep and SonarQube on this. So we designed 2 prompts. First prompt A, single prompt, very basic, no prior knowledge, and we test this on the 7 models, and we do 2 runs per model, so we are sure that we don't have false results. And then we select the top 3 models that performed, and we test multi-stage prompts on these models. So we did that. I'm going to talk about the results a bit later. And then we do the evasion testing once all this is done, so we have good insights on the performance of what case is going to be hardest, what is going to be the easiest, or what is going to be the least seen worldwide. So we tried prompt injection, the simple misleading comments in the file, obfuscation, so bitwise macros, things like that, and decoy security, where we added fake functions that checked maybe before the overflow happens or later, and tried to fool the AI like that. So the models we decided on evaluating were Gemini 3, DeepSeek, DT stands for Deep Think. I don't know why they decided not to call it Think, but I guess. And then Claude Opus, Claude Sonnets, DeepSeek Normal, GPT 5.1, and 5.2. It's worth noting that GPT 5.1 has since been decommissioned by OpenAI, but that's nice. So one thing to note also is that I tried to use as much thinking models as I could. Thinking for AI model increases the reflection time, so might provide more or less better results. When there weren't these thinkings, I just used different models. So how did I grade these models, and what for me was the most important were definitely the detection and the fix. If the model doesn't detect the vulnerability correctly, the rest of the pipeline is broken. And if the fix is not correct, practicality is probably going to be impacted as well. So that's how I scored it. Response time was important as well. The analysis was quite important, but I think that once an AI model detects a vulnerability, the analysis is probably going to be quite good after. And practicality was also important for possible integration in enterprise environments. Does it change your whole code, or does it just change a few things? So, what did prompt A give us? Prompt A showed one thing, so you're going to think by the end of this talk, I am paid by Google, but I assure you I'm not. Prompt A it showed us that the GPT models were not that great. The DeepSeek and Claude Sonnet models scored in the middle. Claude Opus, DeepSeek, DeepThink were good, but the real winner here was Gemini 3 in regards of timing and in regards of output quality. So both of these trade-offs were actually the best ones here. So the spread is quite large, but at the same time not as bad as we could have thought. There were no critical failures, anything that made us change our mind. So it was good first analysis for a single prompt with no prior context. It was quite consequent. One thing to note is the standard derivation. You wouldn't see it in most of the graphs, but when you actually take a deeper look into that, DeepSeek, DeepThink has a big standard derivation. So sometimes it's going to give you the best results, and sometimes it's going to give you the worst ones. In enterprise environment integration, you probably don't want that. You probably want to be reliant on something that would provide good quality outputs most of the time. So it was a good first results. This is more or less the same thing as the past slide. It just gives you a better visual aspect. And it's worth noting that the later GPT model performed worse than the 5.1. Sorry, OpenAI, but yeah, it's just the start. Gemini was absolutely the GOAT here, and the other models stored in the middle. GPT models took a lot of time and didn't score very well, so that's something to keep in mind. But overall, 100% detection rate in all of the Gen AI models, so that's nice. SonarQube, 40%. Only two out of 5 detected, and SemGrep, 1 out of 5. So that can be complicated to digest for some companies, but at the same time, we have to keep in mind that Gen AI does have this semantic analysis. Oh, I touched the HDMI cable.
Give it a wiggle.
Oh. Okay, we don't touch anything anymore. So this semantic analysis from Gen AI, the actual understanding of what's going on, how the functions work together, and the only syntactic analysis from the static scanners that are rule-based or pattern-based does make a difference at the end of the day. So I'm not telling you integrate Gen AI in your company pipeline because it's still black box and they're still vulnerable to a few attacks, but it's worth noting that there is an actual difference between what is used in industry currently. So we tested prompt B after, multi-stage pipeline, and the results were also quite surprising. Didn't provide as much success as we initially thought. Research and literature does push towards using multi-prompts for better results. So 2 out of 3 models were better in analysis on multi-prompting, which does make sense because you give them a bit more time to give you details. But practicality was worse for the 3 models. Practicality was not good because when you only ask for a specific task, it's going to focus and maybe focus a bit too much on getting something better. And the time increase was just crazy on all of them. So was it worth it? Probably not. For a not to increase in performance compared to a single prompt and a time increase of 162%, I wouldn't think it was worthwhile. Then we went to evasion testing. So we tried prompt injection, obfuscation, and decoy security, and AI maintained 100% detection rate here. So it might be attributed to not having a large code bases or more complex code, but in our case, 100% detection rate means that pass all the tests. So the most time-consuming technique we had was obfuscation, which does make sense because when you rename variables and when we say that AI is using a semantic understanding, when you have function names that are quite explicit, it does help the AI understanding what's going on. But then when you straight take out these names and you do bitwise macros, things like that, you give the AI a bit harder time. But at the end of the day, detection was still good, but the time was quite consequently increased. So overall, what does that tell us? That tells us that Gemini 3 in my research is the one that I would recommend for enterprise integration on buffer overflows and memory vulnerable programs to test them and find patches. Clodopus was the most reliable, didn't change that much. This guy was chill, didn't move. A DeepSeek Deepthink might be the one that you would like to stay away from. It has the best result. It scored the best result in some cases, but on some cases for the worst one. So would you really want something you cannot rely on? Probably not. So PA and PB here stands for prompt A and prompt B. And so a bit more insight on how the performance was for the cases. So the first vulnerability, the very simple Stack Overflow vulnerability was quite very logically the easiest one to score for the AI. The red to win, meaning that we overwrote a return address and jumped somewhere else in the program, was scored approximately correctly. Heap was the hardest case for all models, which does tell us that Gen AI models do not master heap overflows quite correctly yet. The CVE model surprisingly wasn't the worst one, but performed mediocrely. And the integer overflow was very variable depending on prompt A or prompt B. So how do we answer research questions now? Did Gen AI detect the buffer overflows? Yes, it did. Did it perform better than the static scanners? Yes, it did. Model selection does matter here because there is a big gap between all models, and you would probably want to use Gemini 3 if you're trying to integrate something like that in enterprise environments. Again, this landscape changes so much and so quick that I'm gonna say that, and tomorrow there's gonna be a new model or something else. Multi-stage prompting did provide negligible to harmful results in our case specifically, so do not apply this to overall logic, but in memory management issues, it did provide harmful results, or negligible. And evasion technique failed, so we did maintain 100% resilience on something that is quite probably the main point of interest right now in AI. So it's a study that did provide some useful results, but later on, of course this was a project in the case of my studies, so I didn't have as much time as I would have to do a whole research project, but we were limited to small benchmarks, only 5 programs, and they were not as big as we would like them. GUI access, so only graphical interface, no API because some models were harder to access within APIs, but it would probably reduce response time if we used API directly. Manual scoring, so I was with my Excel spreadsheets taking notes, but probably if you automate this pipeline, it will give you less subjective results. Scope to buffer overflows, we could make it a bigger scope, and models change. So this is applicable right now, and maybe not even right now, maybe 2 weeks ago. So keep this in mind. Future work, probably test on real larger code bases, see if it performs as well. Automate the scoring pipeline, as said. We could make it a bit bigger and have wider vulnerability classes, try testing format strings, for example, and try more sophisticated evasion techniques such as polymorphic payloads or stuff like that. And later on, maybe AI versus AI. AI would try to design vulnerable code and see if it can bypass AI detection. This would give us quite a nice project. So what can you take from this actually? As I said, Gen AI achieved 100% buffer overflow detection against 20 to 40% on industry standard scanners. Gemini 3 is the optimal model. As I said, I am not paid by Google, but it was clearly the result that stands out. Multi-stage prompt engineering did not improve our outcomes, and all 3 evasion techniques failed on our example here. One thing to note that I didn't write here is that when testing for payloads on the multi-stage prompt pipeline, I asked the models to provide example payloads. The models that provided the most detailed and the best payloads were the Anthropic models. Would that relate with them talking about the Mythos model and releasing something in offensive security? Most probably, but that's just something I saw when doing this research. The Claude models, so Claude Sonnet and Claude Opus, did provide the best offensive security results. So that's all for me. Hopefully I'm still in time. If you have any questions, go for it, yes.
Thanks, 2 questions. Did you track token utilization?
I did not track token utilization. I tracked it in my head, but didn't write it down.
Okay, it'd probably be good to do that. I think also, did you sort of explore sort of reinforcing the prompting through sort of things like skills, sort of, the system prompting?
It's a good question. I did not. So at the time when I started this research, models just started releasing thinking modes. So for me, I did mostly compare the thinking modes without the thinking modes and see what the difference here was. And one thing to take out is that the reflection time does not make for better results. One thing I forgot to mention as well is for the evasion, GPT model. So as you saw at the beginning, for prompt A, GPT model scored the longest and scored the lowest. For evasion, funnily enough, they were the fastest. So the guy just abandoned ship. They shot themselves in the foot and they say, okay, I'm going to give bad results anyway, so I'm just going to do it quick. And this is quite scary because it does show that the most publicly available models and the most publicly publicity model are probably not going to be the best ones. Any other questions? Yes.
It's probably same as token utilization, but did you track cost?
Costs.
Hard currency.
Yeah, so to do this experiment, I did have to get a subscription to ChatGPT Pro and Claude Pro to get access to Claude Opus. But apart from that, I never reached token usage max, token usage. I did do this on a different timestamp, so every day a bit, so I didn't reach this. did not track token usage. So that's a very good point.
Have you looked at local models at all?
Sorry?
Have you looked at running models locally at all?
So I did think about your running Olama, stuff like that, so locally, but I think that the study was more targeted against to a wider public. So, you know, as everyday user, what does that provide to you? So if I run it locally, I would probably use models that are less known or less used, and this use case would really depend on my architecture, GPU, stuff like that, so not as replicable. Yes?
One of the challenges with the traditional static analysis tools is false positives. Did you look at the false positive rate for the kind of AI approach?
Did not write it down, but I can tell you SemGrep was the one that provided the most false positives.
But did the AI tools produce any false positives?
Actually, no. No. So again, this was done on a very small code snippet, and I mean, if I had time, I could show you. Why didn't I not link the GitHub repo with everything? Because I'm currently getting graded on this project, and I might think of publication. By a raise of hand, who thinks this work is worth publishing? Wonderful, then it's done. So yeah, I mean, if you're good in OSINT, you can definitely find the GitHub repo. It's public, but I will not link it here purposefully. But yeah, no false positives on AI.
Yeah, you said, I saw that further your presentation. Is that this year or last year?
This year.
This year, so
Yeah.
you're going to present next week.
Yes, exactly. Yes.
Okay, quick question. I saw you have 5 craft C programs, alright? Is that from the kind of open source or is crafted by yourself?
It's crafted by myself. So within there are a few websites that use CTF challenges with programs, for programs like this. So most of the time they allow you to keep the permissions you execute with. And so I did modify these challenges a bit, where they're taken from well-known CTF platforms and things like that.
Yeah.
Except for the CVE, because there's no publicly available proof of concept. So this was made purely based on the description given on the NVD database.
Yeah, because I'm asking this, I'm kind of worried about if those large language will have a prior knowledge of those existing CVEs. And they saw that before doing the training, or they have to kind of knowledge RAG. So, I don't know, it's kind of poisoning in doing the testing. So how any measure to prevent such?
So what I did is make sure to delete the context and the memory of the models every time to make sure there was no stored stuff when I do repeated tests and repeated test runs. These challenges are not available if you just search them on the internet. You do have to log in, have an account, things like that. So I'm hopeful that it wasn't already present in model's memory, but it is a good point. And this was also a point to see, because the CVE doesn't have any public exploits. So here, if the CVE performed way less than the other tested snippets, we could probably assume that there was some kind of memory or some kind of context. But in this case, they all perform very, very well. So it also shows that, for example, static scanners wouldn't probably flag the CVE because it's not something that is patterned or rule-based. The Gen AI model actually understood the code and saw there was a vulnerability here in the sublogs. I hope that.
Do you have any example of your prompt? Here?
I can if I have.
Let's go.
Wonderful.
Yeah.
And I come back to straight to your question.
I'll talk to you later.
Let's see if it's already open or not. No, it's not. So, for example, this was a very simple.
Okay,
Oh,
I don't
know. Yeah, let's go. So this was the very simple single prompt. So I just tell it and give it context. So this was based on research as well. This is called on the zero shot policy, meaning that you don't provide any examples or context to the AI. Just simply tell it what you want it to do. You're a security tool. Analyze this code for possible security vulnerabilities. It's worth noting that I didn't say there are vulnerabilities here. I said there was possible security vulnerabilities. It could provide more hallucination rates if you said there was a vulnerability and there wasn't in the source code. So that was very important. And I just gave it the categories I was evaluating here without many details and evaluated the outputs. To compare, for example, this was prompt B. So every time I put it in a specific context, for example, for the detection, you're a security analyzer. For later on the analysis, you're a researcher, and for the fix, you're a coding engineer. So every time give it a good context and ask it more specifically what you want, which does provide way more detail, but at the end of the day, the outputs mostly stays the same.
Sorry.
No, it's not. It was more just about the publishing concept. There's a mantra in academia, publish or die.
Okay.
But also the benefit of publishing is you get to interact with the community, you get to interact with you, and it's really a timeline as you begin your career or your interests. So there's a lot of good reasons for sharing. It's called open source ecology.
Yeah, I agree with that.
It's a really quick one. Do you think that your multi-prompt, it didn't make that much of a difference because you were using those thinking models, which in many ways they're kind of reflecting more as they go along anyway? It might have had more of a difference if it was all standard models or kind of the older style.
I feel the biggest difference would be definitely in timing speed, which makes sense because the thinking models are here to make the models forcefully think longer. The complexity of the response probably was impacted, so you would have more complete response, maybe better analysis on something with the thinking mode on than
I was thinking that maybe the multi-prompt didn't have as much of an impact because you were using thinking models basically.
That's a good point. I didn't try this, so it's a good point. Okay.
Just quick reflection, if it works with the buffer overflow, definitely can work with other types of malicious code.
Yes.
So if you pursue a publication, think about if you have to extend it to other attack types.
As I said, maybe I want to stay in this dimension because I think the static scanners would perform better on SQL injections or things like that. And this is quite a specific subject, so I really want to evaluate it on this subject. Further, probably format strings could be worthwhile. Reading data, so then trying to see if it can grab the content of a file on file system, but then I would have to build more architecture and not just code snippets. But to extend this research, this could be worthwhile.
We're very
Okay.
brilliant. Thank you
very
very
much.
much, and thank you.